Hi, my name is Ali from Team 12. I follow the Homework 1 instructions file to carefully place the power supply module, 2 resistors, a push button, an NPN transistor, an LED and 5 jumper wires on the solderless breadboard, as shown in the video. In this NOT gate circuit, I use a single switch, SV1, as the input. It connects to the base of an NPN transistor Q1 through a 2 kΩ resistor R1, which regulates the current. When SV1 is open, meaning the input is low, no current reaches Q1, keeping it off. This allows current to flow through the 330 ohm resistor R2 and the LED D1, lighting it up to indicate a high output. When I press SV1, meaning the input is high, current flows to Q1, turning it on. This creates a direct path to the ground, bypassing the LED, which turns off to indicate a low output. This setup shows the NOT gate's function. A low input gives a high output, and a high input gives a low output.
Hello everyone, I am Murat Akverdi, and in this video I assembled a circuit on solderless breadboard using a power supply module, resistors, push buttons, NPN transistors, and LED and jumper wires following the Homework 1 instructions diagram. In this AND gate circuit, switches SW1 and SW2 act as inputs, controlling the transistor Q2 and Q3 through 2K resistors. When both switches are pressed, Q2 and Q3 turn on, grounding Q1's base and keeping it off. This allows current to flow through R2 and the LED, lighting it up, indicating a high output. If either switch remains open, Q2 or Q3 stays off, preventing Q1's base from being pulled low. This turns Q1 on, creating a direct path to ground by passing the LED and keeping it off, signaling a low output. This setup correctly demonstrates an AND gate where LED lights up only when both inputs are high.
Hello everyone, I am Nihat Nazade. In this video, I assembled the component on solderless breadboard. I positioned to the power supply module 4 resistor, 2 small push button, 3 NPN transistor, LED and 11 jumper wires, ensuring the accurate placements as shown in the accompanying image. In this OR gate, the power supply module delivers the voltage to the circuit with the 2 switch SW1 and SW2, which serves as the input. Each switch is connected to the base of the NPN transistor Q2 or Q3 through the 2 car resistors RB and R3, regulating the base current of this transistor. Q3 and Q2 are arranged in the parallel with their collector connected to the base of the third transistor. Q1 via the another 2 car resistors R4 when either SW1 or SW2 is pressed, meaning at least one input is high. Current flows through the corresponding resistor to the base of Q2 and Q3, turning the respective transistor on. This creates the pathway for current to flow from the power supply through R4 to the ground via the activated transistor, grounding to the base of Q1 and keeping it off. With the Q1 turned off, current from the power supply passes through the 313 resistors R2 and the LED D1 to the ground, causing the LED to light up and indicating the high output. If neither switch is pressed, meaning both inputs are low, Q2 and Q3 remain off, preventing any current from grounding to the base of Q1. This allows Q1 to turn on, creating the direct path from the power supply to the ground. As the result, the current bypasses the LED, keeping it off and signaling the low output. This configuration effectively demonstrates the OR gate principle, where the LED lights up when at least one input is high, while it remains off only when both inputs are low.